I want you to think about how old groundwater is. I googled about a year or so ago, groundwater and age, and I found this. This is apparently a Japanese company that sells water that is claimed to be 12 years old. They don't say exactly what they mean by this, but from the look of the water in the can, I suspect it's been in a barrel for 12 years. So let me change the question slightly. Let me refine the question. I want to think about how old groundwater is. And I just have a little cartoon here of water that enters a groundwater system here and flows down to a location where someone may be pumping it out for a domestic supply. And the first thing to say is that groundwater is not like a bathtub. The groundwater reservoir is not like a bathtub. The water is not mixing and swirling underneath our feet. It's not well mixed at all. And so if we were to draw contours of water age on that plot, it might look something like this. The groundwater system is layered, and so the younger water sits above the older water, and the water will get older as it moves through the system. And in this cartoon, this bore is pumping out water that's about 25 years old, and as the water flows further down, it might flow to a lake or to a river after 50 years. So in this context, when we talk about the age of groundwater, I'm talking about how long it's been in the underground system, or how long since that water fell as rain or as snow, usually. How do we tell how old the groundwater is? Usually looking at the chemistry of the water. So there are a number of components, compounds in the water that we can measure that tell us how old they are. And I've just got a little diagram that shows some of them. I don't want to go through them all. And at the old end, we can use carbon-14. If the water is several thousands of years old, we can use carbon-14 to tell how old it is. The same way that archaeologists date bones with carbon-14, we can date the carbonate salts that are present in the water. At the extreme other end is radioactive radon, which is naturally present in the ground. That has a half-life of only 4 days, and so we can date water that's a few days to a couple of weeks old. The other one that I'll talk a little bit more about is chlorofluorocarbons. We've heard a lot about the chlorofluorocarbons. They're in the atmosphere. We've produced them, refrigerators, air conditioning systems. They're a gas, and like all gases, they dissolve in water, so they dissolve in rain. And if we measure the concentration, we can tell how old the water is. And this is just a diagram that would show you what the CFC concentration for two different CFCs would be over time. Before we started making them, back in the 40s, they didn't exist, so old water will have none. And then from the concentration, in the 88, we banned further production in the Western world, and so they've started to decrease, but only very slowly. So we can measure these things and tell how old the water is. Change track a little bit now. So this is a diagram that most of you will have seen sometime, perhaps a long time ago in high school, and it just shows the hydrological cycle. And there are various water reservoirs, the ocean, the groundwater system, streams and lakes, glaciers. And we know a lot about most of these groundwater reservoirs. What we know a lot less about is the interaction between them, the boundaries between them. How does the groundwater interact with the ocean? How does the groundwater interact with lakes and wetlands? And this is where the interesting science is. So just talk a little bit more about some of those ecosystem boundaries, but they're also discipline boundaries. because we tend to divide ourselves up into disciplines. And as I said, groundwater will interact with wetlands, with rivers. The reason that rivers still have water in when it's not raining is because it's groundwater flowing into rivers. Terrestrial vegetation will often have their roots, their feet down in the groundwater, and they use that as the water supply. Marine ecosystems are particularly interesting and particularly poorly studied, and there is some evidence that flow of fresh groundwater into marine systems creates areas of slightly less saline water that can be very important for fish breeding. So it's something that we need to learn a lot more about. And there's even little bugs that live within the groundwater itself. We know they're there, we don't know very much about them, we don't know what they do, and we don't know what might happen if we kill them. But this is another frontier area trying to understand the different aspects of groundwater.